All right, want to continue the video now. This is section 1.1 video part 2. What I want to do, I told you that I would get you to take notes a little bit differently than how you would take notes in class. And there's reasons why I do it this way. I'll explain that in just a few minutes. So here's what I'm going to do. I'm going to put the problems up, and I will say, pause the video and copy this problem. Then I'm going to let you copy the next problem. I'll say pause the video, copy this problem. I'm going to let you copy every problem in this whole section. Then after we do that, then you can sit back, watch your video, and I'm going to cover it up and go through it line by line with you. But you'll have it in your notes, and that way you're not trying to copy, pause the video, and listen to me all at the same time. I think that'll work better for you. So let's do that. All right, so here we go. I told you, go ahead and write these instructions down. The instructions here, solve the following equations. Solve the following equations. Let me see if you can see. Okay, pause the video now. Okay, I'm assuming you just copied those. Now let me give you the next one. This next example, pause the video now. All right, next example. Okay, pause the video now. All right, next example. Pause the video now. And then the last one, number 6. Pause the video now. Okay, let's keep going. And once you get all these copied, I promise I'm going to go over this with you. Okay. These two, pause the video now and copy. Okay. This next one, pause. Okay. This next one, pause. Okay. The next one, pause. And then this last one, pause. Okay, so you should now have all of the problems that I want to go over with you in this section copied. So what I want to do now is back up and go over these slowly with you so that these, make sure you understand how to do these. So here we go. We're going to do these one at a time. And I will point to them right here. All right. This is a linear equation. X is to the first power. Now, if you'll look back at your steps I gave you, step 1 doesn't apply. Because step 1 says get rid of fractions and decimals. There's not any. Step 2 says get rid of grouping symbols. So the first 2 steps that I gave you on how to work these problems is not applicable here. But step 3 is. Step 3 says get your variable terms on one side, get your number terms on the other. So remember, the way you do this, to get rid of the subtracting 7, what do you have to do to both sides? You have to add 7 to both sides. So you plus 7 on the left, plus 7 on the right. Now I'm aware that some of you have been taught, move that 3 over and swap the sign. I'm not going to try to reinvent the wheel on you, but I will say you're not moving that 7 over. I know that it looks like that, but you're really adding 7 to both sides. but whatever works for you there. So when you do, we'll get 2x equal 10. And here that is ax equal b. And this a, this is what we call the coefficient of x. So this is 2 times x. And remember, the way you undo multiplication is divide. But the golden rule to equations, whatever you do to one side, you must do to the other. So divide both sides by 2 to get x equal 5. Now this problem right here should be extremely easy for you. This is nothing but a review. Now let me show you that this works. If you let x be 5, 2 times 5 is 10. 10 minus 7 is 3. So not only is that the solution, it is the only solution. So this linear equation has one answer. That's a finite number. So this is also called a conditional equation because it only had one answer. Most of the linear equations that we look at will fall into this category. All right, so let's look at this next one. 5x minus 4 equal 3x minus 16. Now, if you remember from algebra, this is what we call the two-step problem. So what you have to do here is you have to get the x's on one side, but then you have to get the numbers on the other. And if you do that in one step, it looks like this. Now, you do this in as many steps as it takes you. I'm fine with you doing it in 2 steps. But you're really plus 4 to both sides, minus 3x on both sides. But that's what it looks like, and hopefully everybody in here can do that in one step. But if you can't, you do it in as many steps as you need to. Now you're left with 2x equal negative 12. There it is again, 8x equal b. Divide by the coefficient of x. But whatever you do to one side, you have to do to the other to get x equal negative 6. Okay, now in this next problem. In this next problem, it's a little different than the first two because it has grouping symbols. Another word for grouping symbols is either parentheses or brackets. Now, remember the way you get rid of parentheses in mathematics, not just throw them away. You have to multiply what's in this parentheses by what's in front of the parentheses. You say, well, Mr. Ryan, I thought we're supposed to do what's in the parentheses first. We do if you can do anything in the parentheses. But you can't subtract these two terms together because they're unlike terms. So doing anything in here is out. But I can multiply what's in here by this 2 out front. This is what we call in mathematics the distributive property. So I'm going to bring the 5 down and the plus down, and I'm going to do 2 times 3 and then 2 times negative 2. When I do that, 2 times 3 is 6x. 2 times negative 2 is negative 4. The right side, there's nothing to do, so bring that down. Now, I've distributed, but I want to clean up both sides. So always do everything you can on both sides first. Well, this left side, this is a variable term. But that's a number term and that's a number term. So you can combine these two terms. So I'm going to bring the 6x down. I like putting my x's first. It's positive. So it'll be 6x, and then 5 minus 4 would be plus 1. If you write it 1 plus 6x, that's okay. Now, when you get to here, you're back to that two-step process that you see all the time in linear equations. So if you get your x's on the left and numbers on the right, and by the way, if you get your x's on the right and numbers on the left, you'll get the same answer. So 6x minus 7x is negative 1x. And it's very important that you're able to add, subtract, multiply, and divide positive and negative numbers. If you're rusty or unsure of yourself, you can use your calculator to do that. So 6 minus 7 is negative 1x. There's the coefficient, negative 1. You say, Mr. Ryan, I thought you said that this couldn't be 0. I said, no, this one can't be. The number in front of x can't be 0. So to get rid of the coefficient of x, you divide by it, not the opposite of it. You divide by whatever number that is. Whatever you do to one side, you must do to the other. The negative 1's cancel and leaves 1x, and then 0 over any number is 0. You don't see that? Take your calculator and divide that. And you'll see that you get 0. Okay, let's do another one. 4x minus 2 times x minus 3 equals 6 minus x minus 8. Okay, I have a grouping symbol. What's in front of this grouping symbol? A 2. More specifically, negative 2 times what's in here. Grouping symbol. What's in front of the grouping symbol? A 6. No, that's not what's in front of this grouping symbol. A negative 1. So you're not distributing with the 6. You're distributing with a negative 1 times what's in here. All right, so I'm going to distribute here and distribute with that negative 1. When I do that, bring down the 4x. Negative 2 times x is negative 2x. Negative 2 times negative 3 is plus 6. Equals, right side, 6. Negative 1 times x is negative 1x. Negative 1 times negative 8 is plus 8. All right, now come down the next step. Simplify what you can over here. I can combine these two terms because they're variable terms. 4x minus 2x is 2x, then bring down the plus 6. Over here, you can add this number and this number together, but you can't combine them with a variable term. So bring the negative x down, and 6 plus 8 is plus 14. So 4x minus 2x is 2x plus 6. Brought the negative x down, and 6 plus 8 is 14. Now you're back to that same two-step problem again. And by the way, there it is again, ax equal b. And you divide by the coefficient to get 8 over 3. Now, a couple of things right quick. First, in this course, we don't ever write our answer as decimals. So if this doesn't reduce, just leave it like that. For instance, if you remember from other math classes, if you remember how to change this to a mixed number, this is 2 2/3. I do not care that you do that. So just leave it 8/3. Now, if it will reduce, by all means do that. For instance, if this was 8 over 6, 2 goes into both of those. So 2 would go into 8 4 times, 2 would go into 6 3 times. So do reduce it if it'll reduce. But if it doesn't, leave it in reduced fractional form. So 8/3 would be the answer there that I'll want. Okay, now this next one. You already know what's going to happen in this next one, but let's pretend like we don't know. That's why I told you just to sit back and watch with me. All right, when I look at this problem, it looks just like the others, right? I mean, there's nothing that jumps out or says, oh my gosh, this problem right here is going to be something different. Nothing bounces out at me at all on this. So, all right, what do? Well, get rid of grouping symbols first. So I'm going to multiply by what's in front of that grouping symbol. When I distribute there, I get 4x equal 28. Now, get your x's on one side, get your numbers on the other. When you do, you have 4x minus 4x equals 30 minus 28. Now, what happens here that has not happened in any of the problems before? The variables cancel. So I've got 0x. Now you say, well, Mr. Rayner, right up here in problem number 3, the variables canceled. No, they didn't. The numbers canceled, but the variables didn't. In this one, 4x minus 4x. Let me say this first. 4x minus 4x is not x. If you write just x, that's understood 1x. So you have to put the 0 here. So this 0x equal 2. All right, remember our stipulation? The number in front of x cannot be 0. Now, I didn't tell you why, but I will tell you now. What have we been doing in these other problems with the number that's in front of x? How do we get rid of it? We divide by it. We call that the coefficient. This problem right here, how do we get rid of the 3? We divided by it. Anytime your variables cancels, that means there's a 0 in front of this x. The reason that stipulation said A, this is B, A could not be 0 is in mathematics, the one thing you can never do in mathematics in division is you can never divide by 0. You can divide into it, that's not a problem, but you can't divide by it. So in this problem right here, if you divide both sides by 0, you can't do that. If you don't believe me, take your calculator and take 2 divided by 0. If you do that, you will see that your calculator will give you an error. It can't compute that. That's why this number right here, if it's ever 0, it means something special. Okay, so you may want to write this down. If the coefficient of x is 0, the answer will be no solution or all real numbers. And actually, I think I've already given you that note when I gave you the steps, the 4th step in solving linear equations. So actually, I think you've already written that down once. So that means this problem right here is either no solution or everything works. So how do we tell? Here's what you do. I want to read this out loud. Look at what this says. 0 times what is 2? Can you take 0 times anything and ever get 2? No. You can't take 0 times something and get 2. There's nothing that will make that work. This problem has no solution. Now, I probably will not ask you what kind of equation it is, but you do need to know that it's no solution. So if this is 0x equal 2, 0x equal 5, 0x equal -3, if this is 0x equal any number, it's always going to be no solution. Now you say, well, what if it's 0x equals 0? Hold up, I'm not ready to answer that yet. But if it's 0x equal any number over here that's not 0, it's always going to be no solution. Now, let's look at the next example. When you look at this next example, it looks just like the others, doesn't it? Okay, let's distribute. Now get the x's on one side, numbers on the other. And when you do, you get 6x minus 6x, 0x, there it is again. So, based on the note that I gave you, if this happens, if your variables leaves the problem, if the variables cancel, the answer is either nothing works or everything works. Well, let's look at what it says. 0 times what is 0? 0 times anything is 0. 0 times 1, 0 times 2, 0 times -7, 0 times 50, 0 times 7.3. 0 times anything is going to give you 0. So if you get 0x equals 0, the answer to that is all real numbers, or an identity equation. So, all real numbers will always be 0x equal 0. Always. No solution will always be 0x equals some other number. Now, if the x's doesn't go to 0, you're going to always have an answer. You'll have an answer. But if the variables goes to 0, it's no solution if it's 0x equals some number. If it's 0x equals 0, it's all real numbers. So I'm not going to take time to do this, but let me wrap up this video by saying this. So if I told everybody that's listening to me, pick any number you want to for x. So like if I take 5. If I put 5 here and 5 here and do both sides, they'll be equal. But any number you pick and put it here and here would also work. Every number you picked, this would always be true. But over on the previous one, absolutely nothing you pick will work. But in the first 4, only the answer you found would work. So the first 4 had a finite number of answers. The fifth example we just worked had no solution. It's called a contradiction equation. And then the last one, everything works. Now, will I be able to look at the problem originally and tell? No, not always. These problems can be really long and still end up being this. So you don't have to be able to look at that problem before you work it and tell. But you will always know if it's all real numbers because this will happen. You will always know that it's no solution because this right here will happen. 0x equals some number. Okay, so that concludes the first 6 examples. So what we will do in the next video is we will pick up with the 7th example, and you've already written these examples down. So in the 7th example, it's one dealing with fractions, equations involving fractions. So that concludes this video. Next video.